Far right, Michael Vasco. I'd like to thank the board, faculty, staff, Dr. Appel, ladies and gentlemen. We're going to go over the Semantic Web Crawler open source project, and I'm going to give a brief overview of the concept and plan, and after that, Manny will take over, and then Michael. So, Semantic Web Crawler. What is a web crawler? Well, it's a computer program. It's called a webbot, and what does that mean? It's a robotic program that stems off a list of policies. And these policies include a list of URLs. These are called the seeds. And from that list, the crawler will go out to these URLs and look for any types of hyperlinks that are involved, that are incorporated within these URLs. And it'll snag those and add it to the list. And so the list will keep growing and growing. And the semantic web, or the web crawler will just go out, extract the data, and bring it in a blind fashion. This whole ball is called the crawl frontier. Next. So why semantic web crawler? Well, like I said, the typical web crawler just branches out blindly. It doesn't really have a knowledge of the data. It just simply goes out, extracts it. The problem with that is that some of the data can be repetitive. Some of the data can be stale. Some of the data can be old. It doesn't know. It's just going out and grabbing it. The difference, in contrast, is the semantic web crawler has the ability to actually understand the data and can parse through the data, and depending on how the core is written, can grab the actual data that's critical to the user requirements. Next, please. So, like I said, the problem, very few web crawlers are built in C++ or a low-level language. The perception is that the ability to modify the crawler outweighs the performance aspect, but we'll show you differently later on in our demonstration. Also, the scripting languages that most web crawlers are built on tend to run slower because they have to be interpreted. They have to go through that extra step, and that eats up time. Next, please. So the solution, of course, like I mentioned, we're going to be developing our web crawler in C++ simply for sheer speed. We wanted to get the fastest turnaround web crawler possible, and we've been very happy when we've developed that. The requirements of the web crawler are built directly into the object-oriented core. And what that means is that via a command line interface, we can talk to that core and get the requirements and bring them and pare down those requirements, as opposed to just having a list of URLs and the policies and just going out and getting data, some of that data might be unwanted. So we can talk directly to the core. Now, these cores are specific to the user requirements and needs. So the crawler will have multi-cores depending on what the business requires. Next, please. So here is a case study that we used over at the Bayan Foundation. This is a tool, and what we were able to do was select some different crawlers. And what we found is that if you notice some of the common names such as Python, PHP, Ruby, Perl, these are the scripting languages that use the web crawlers. And you can see that when we gave them the list of policies and URLs, they were around 50 seconds up to 100 seconds. In contrast, C++ at the top of the list, 1.2 seconds, and Java is a really good contender too, at 2 to 3 seconds. Or we selected C++ because we wanted to see what the fastest web crawler we could make. With any plan, there's always going to be risk associated with it. We've identified a number of risks, the top 7, and we're going to focus on the top 4, being staff size, of course, with a 3-man team, experience, where we're newly graduated, process definition, product size, and development environment. Well, how do you combat those risks? Well, we have decided to utilize the open source community to be involved with our project. Now, what that means is that instead of a 3-man team, we have the resources of the entire foundation and their skills and the developers, and we can extract their knowledge and get their feedback into our project because we have it on a GitHub platform, which we'll be talking about later. And once we get their input, we can analyze it and integrate it with our system as we see fit. So that's how we combat it. this time I'd like to turn over the presentation to Manny. Thank you.
Thank you, Dave. Good morning, everyone. As Dave mentioned, my name is Manny, and I will be giving an overview of the requirements and design of the semantic web crawler. Next, please. These are the functional requirements for the semantic web crawler. There are 6 in total: the HTTP/HTTPS crawler, the input-output operation, the content storage, the HTML and data parser, the data management, and the user interface. Out of these 6, I will discuss 3 that our team consider the most important. Next, please. The input-output operation allows the crawler arguments to be entered into a command line. It figures out the different API commands and executes them in the proper order. And lastly, it saves all relevant data crawled by the core into a comma-separated value, also known as a CSV file for the database. Next, please. The second function is the crawler. It interacts with the internet and is responsible for downloading the web pages. It uses a Linux wget command to cache the HTML into a hash file. It also creates the necessary sockets and system needed to grab that data. Next, please. And finally, the HTML and data parser, which is responsible for loading the cache page data into the application. It uses a regular expression, also known as a regex, to separate that data from the HTML, and it looks for the URLs so the program, the SWC program, can go to page. Next, please. Can move from page to page. All right. Now we'll be talking about the non-functional requirements, which are quite a few: efficiency, reliability, usability, correctability, maintainability, portability, testability, modifiability, availability, performance, and security. Once again, out of all these many, and we will be talking about the 2 most important ones that our team considers the most important. Next, please. Performance. Performance is really concerned with utilization and throughput. And an example of a scenario for performance is that the process shall be completed within a latency of 1 second, and all the data must be complete and accurate. A tactic to solve this scenario is to make sure that the resource management makes available that all the available resources are fully utilized or increased in the compiled environment. Next, please. The second non-functional requirement is modifiability. Modifiability, it weeds out errors and it improves the performance across many platforms. An example of a scenario for modifiability is as the user interacts with the software, he or she will change that data per crawl. A tactic to solve that scenario would utilize polymorphing to better understand the user. Next, please. This is the design flow for our program. Beginning with the user interface and through input-output, the user inputs the websites that one search and enters it, and at the HTML data parser, from there, it will go straight to the data content to look if it's already cached. If it is not cached, it will go back to the HTML and data parser, and from there, it will be sent to the internet to crawl the internet, and it pulls out the websites that it needs. Once it is done, it will go back to the HTML and data parser, and it will send it down to the content storage to create a cache folder, and from there, it will parse the data that the user is looking for and send it to the database management, where it presents it to the user. This is all done via input-output operation, and bear in mind this is all done at the same time. Now we'll be passing it to Michael to give an overview of the testing and user.
Thank you, Manny. Appreciate it. I'm going to be reviewing real quick our testing and user parameters. Essentially, what we needed to do in order to be able to build this, what we needed to do in order to be able to focus on how we're going to take this project beyond just the classroom environment. This is an open source project after all, so let's go ahead and get started. There will eventually be a graphical user interface, like Manny mentioned. It will be as simple as possible. It'll have your regular registration, login information. It'll have your activity selection, allowing the user to choose what it is that they want to do. Basic profile management and system admin type functionality. It'll have database management. This is where the users go out and essentially pull the crawled data once it's been crawled and can convert it into whatever format, Excel and so forth, that they require to use. And finally, the most important component of the graphical user interface that we'll eventually implement is the actual initiate web crawler. This is where the user will essentially put in the link or the specific URL, the semantic URL that they want pulled, and select the type of semantic template, which we'll be discussing shortly, that they specifically want pulled for this specific website. Right? So, like I said before, this is an open source project. We do have a GitHub repository at github.com/vastos/semantic web crawler. Anyone can go and view the code. Anyone can go and submit patches, submit changes, download the code, test it out themselves, do commits. We will, as a team, be responsible for making sure we check the code, making sure that with any submitted changes, we actually have a number of people that have already joined the GitHub repository or watching the project. If any of them submit any specific changes, do any Git pushes to us, we'll take a look at the code, we'll test it before we actually push it out to master and implement it. So this is a fully functional open source project that anybody can participate in. So if you guys, if this is something that you're interested in, or if this is something that you think your company can use, definitely join us and participate in it. Go ahead. All right, so what are we testing for? We're testing to make sure it's highly scalable. We're testing to make sure that any and all crawling functionality, is supported in this. Basically, most crawlers have specific formats, specific types: HTTP, HTTPS, FTP. At some point down the line, we'll implement as well. We're making sure that any semantic data that's pulled from the actual path is input into the database properly. And we're finally making sure that any commands that are given from the user interface to the specific core of the project, that it understands the command line arguments that we're putting in there. All right? Our testing platforms, obviously, this is all built in command line Linux. The reason for this is specifically because we figured that if somebody's running a crawler, they're most likely going to be running on a server somewhere. They're not going to be running it on their desktop. We're using Amazon EC2 virtual cloud instances to test this stuff out and make sure that it's scalable out. We're using S3 cloud storage down the line in order to be able to have multiple servers running multiple crawls, and they all share the same cache environment specifically for these websites. So if both servers are crawling the same exact site at some point, but for different information, they can share the same cache. And we're using Amazon's RDS service for database storage. So essentially, it's basically MySQL. The crawler pulls the information, stores it into a MySQL database. We want to make sure that it's scalable. Go ahead. So finally, why semantic web crawler? Why not just a regular web crawler, like Dave mentioned? If you go to schema.org, you'll see templates for what are called semantic web templating. You have templates for products, you have templates for reviews of restaurants, you have templates for places, organizations, everything you can possibly imagine. That what they've done is allowed you to build a templatized version of just semantic data. And every website is implementing it. Sears, Kmart, and Adorama.com alone, there are three of the sites that I know for a fact just recently implemented schema.org templates on all of their products. So we can potentially, down the line, once the project is finalized, we can go, for product specifically, we can go and download it. So ultimately, our goal is to get to the point where we have modules for all of these specific functions. Yep. Good? Good. Okay. All right, so we're going to go ahead and jump into our prototype demo, so you guys can sort of see, like I mentioned before, this is just a proof of concept. This is to show that we can do the regular expressions, that we can do the arguments within a compiled environment. What we're going to be showing you is a single compiled application. It's all that they kick off.
This is the fun part, guys. Okay, so we get to see how our web crawler is working, our semantic web crawler. So what we want to do is, of course, prove that the concept works, and get an actual input from the audience. So think of some websites. I need three websites. National University.
National.
NU.edu.
http://nu.edu.
Two more. What do you guys got?
www. Doesn't matter. We can do either one.
Anyone have any other websites? Just top your head.
FoxNews.com.
What's it?
Fox News.
Okay, great. Anything else?
Do a GitHub.
GitHub. Perfect.
Great. Outstanding.
And throw GoDaddy in there.
So,
All right, go ahead.
so what we're going to see here, and this is a great example because these are real life examples. We're not just, testing things that we've tested before. So, and what you're seeing right now, these are the actual HTML bits of data that are coming in to our cache folder. basically what just happened is that we went out to those websites, extracted the HTML, and now let's go ahead and go to our cache folder, Michael, and show what happened and how those.
Okay, so this is the application.
Right.
Go ahead.
So we're opening up our cache folder, and these are the 4 websites we just talked about. Go ahead and open one of those up here, and there's our GitHub right there. And what you're actually seeing is not the website itself. This is you're seeing the HTML rendered version of the website. And then you can see up here there's the unique cache ID for that HTML rendered website. So let's look at the other ones to make sure we're of course just proving concept right now. There it is, GoDaddy. So this is just the high level right now. We're looking at the top of the pyramid because what we've just done is we've extracted the HTML, right? We may not need that whole HTML, and our next process we're going to be showing what are we going to do with this big HTML file, Vision National. And last but not least, did we look at Fox?
Yeah.
Okay, great.
All right, man.
My presentation is we're going to show you how our program reloads the arguments. Michael's going to delete the cache folder.
Sorry, one second. All right. Put the trash.
And once again, he will retype in the websites. And as you can see, it's reloading. And the reason why we use the cache argument is to not interfere with the website bandwidth. And as you saw, there's a very difference. It's faster in speed. And now we'll pass it along to Michael to talk about the HTML and data parser part of our program.
Okay, so as you guys,
Real quick, what just happened there was that the cache folder was regenerated. Okay, as you saw, Michael deleted the cache folder, then it was regenerated and populated back with HTML data.
awesome. Thank you, Dave. Thank you, Manny. So essentially, the next example that we're going to give you, just as a real quick, simple example, I'm going to go ahead and I'm going to enter in my personal website, michaelbassos.com. And as you can see, just like we did with all the other ones, it's going to go through the process of downloading. Boom. And what you're seeing running through the screen, this is the actual HTML code. It's just basically set to print out to the screen once it's downloaded the actual code. So what we're going to do here is you can see here it's downloaded. There's an extra cache file on there. So what we're going to do is, now that you've seen that it's downloaded the code, now that you've seen that it's downloaded michaelbassos.com, we're going to actually delete this again one more time. And we're not just going to download the page again, but we're actually going to give it an argument. So we're going to give it an li argument. So what I want to do is I want to find anything that is between li HTML brackets. So I'm basically doing regular expression, simple regex. You can see right here, I'm asking it to basically pull for me anything that's in between the li brackets of my web page. Going through the same process, and boom, there we have a regular expression with the li statement, basically the HTML within the specific page that pulls anything that's in between the li brackets. Like I said before, this is a proof of concept. The idea here being that we're able to show you what we can do with the C++ object-oriented core with regular expressions being fed in versus being programmed into the document. But the ideal situation here is that we would build modules for each of the schema.org prototypes, and these modules would essentially allow us to just point to a website, and it would basically do all that regular expression in a compiled environment. And once it's done that, it pulls and gives us all of those schema.org templates. So if it's a product template, if it's a whatever template, it grabs that information from us. Go ahead and go back here. Anybody have any questions?
All right. So, questions? How much better was C++ with HTML?
Ballpark. By a matter of just like microseconds. Java, our purpose specifically for using C++ instead of Java isn't just necessarily speed. It's also the fact that when the user, for example, downloads this application, it's a single executable on the Linux platform versus the user having to go through the process of downloading the Java runtime environment, making sure that it's applicable. Essentially, you could have a server auto-generated, pull in with a single file, doesn't need to update, or anything like that. You can just execute it versus making sure that all of these environments are running and operating, which is no different in most cases than, as an example, PHP or Perl or other systems that are also Perl. So.
Yeah, we actually anticipated that question from the exam. So as you can saw,
We started with Java first.
yeah,
We started with Java first.
and through our tools with the Debian, we saw very close. However, we want it to be